for being early. I think you want to start now. Guys, can you hear me?
Yes.
Okay. So let us start now. I think I asked you to solve something. Did you try to solve it? Okay. It's okay. Let me share my screen now. Can start now. Okay. So you're able to see my screen now, right? Okay. As I was explaining to you about the case of complex pole, the thing I ask you to solve, I don't know if you did solve what I asked you to solve, but it's okay. You can try now to solve. Give me a minute. Okay. Okay. So we are trying now to solve a case where we have complex poles. So what we can do here is this now. Let's take the example number 2, the one I gave to you, the example number 2. I'll do this later. I think it was something like, let me try to open this. Where is it now? Okay. Is it now? Okay. Okay. Okay, let's try now to solve this problem. I want to plug in my. So we have a case where we have okay. I want to ask a question. Did you try to solve those 3 problems I sent? I asked you to solve. Hello, guys. Guys, can you hear me?
Yes.
So please switch off your microphone. So I think
I say we can hear you.
I don't know. Okay. Thanks. Okay. I gave you a problem where it was kind of, let's say it was, I think if I remember, x square plus 5x plus, I think it was 4, which is equal to 0. Okay. Now, no, I think this one won't really give us what I want to find. Let's use this one. Okay, let's just change this one and put here. Let's say put here 4 4x. There we have 5. Okay, so in this case, when we want to find the root of this one, we'll have delta, which is going to be equal to b square minus 4ac, where a is equal to 1 and b, which is equal to 4, and c is equal to 5. So it's going to be 16 minus 20. Okay, so this is going to give us minus 4. Okay, so we all know that in real number, there is no root square of negative number. So we have negative number, we need to find the delta here, root square delta of minus 4. So this is going to lead us now to convert it in a complex number, which is going to be j root square of 4. Okay, where this j, when you put it inside, is going to be, we know that j square is equal to minus 1. Guys, can you remember this? So now we're going to find our x1 and x2, which is going to be given by, let's say, here we have b square, which is minus b, which is going to be minus 4 plus minus j times 2 over 2 equals 2a, and this one is going to give us x1 is going to be minus 2 plus 2j. This one is going to be minus 2 minus 2j. Okay, guys, so we are together. You can see that now we have two complex number. So this is the case that we are going now to see how we can be able to solve a problem where we have complex number, where we have complex number. So let us see in our notes. Must have some exercises there. We have one. Okay. So, and remember, let me just show you this. Remember when we have something like this, so that means our equation, which was, let's say this one, which was x square plus 4x plus 5 can be also equal to, let's say, equal to x plus, or let's say plus, or let me just write it minus, can be x minus 2x, oh sorry, where is it, minus 2 minus 2j when we close the brackets. Guys, there is a mistake, you didn't even see it. I think this one is going to be j here. Sorry, it won't be 2j, it's going to be j there. Because this one times 2 is going to give us 1. So this one, okay. So let me just put this one here. Okay. Okay, so good. Let's go. We'll move this one. Okay, so this is gonna be minus j times x minus, this one must be plus. When we change it, must be plus. This one also must be plus 2 plus j. Guys, are we together? Hello, guys.
Yes, sir, yes.
So do you see what I'm doing here?
Yes, we see.
Okay, thank you very much. But just when you see a mistake, don't let it go like that. Say, no, sir, there is a, you should write like this. It's going to be important. Some of us can copy it with that mistake. So it's not good. So now let's go now to our slides. You can see there is one example that is given to us. So they say, they give us this problem here. Then they say we should find the inverse Laplace transform of this one. So this one is in the frequency domain. So let's go. We can let's go here. We can delete this one. Okay, we can delete everything there. Okay. Let me enlarge the screen. Okay. So we have our problem there. So they say I think it's s plus 3 over s plus 1, and again the bracket, s square plus, I think, let's see what is happening here. Plus plus 4s plus 5. So this is what they're asking us to solve. So the first thing that we are supposed to do, let's call this one is equal to f s. Okay. So the first thing that we must solve now here is to find the poles of this function. How many poles do we have here? Guys, how many poles? Guys, how many poles do we have?
Two.
3 poles. 3 poles.
Three poles.
Yeah. So the first pole we're gonna be P1. P1 is going to be, let's say, s plus 1 is equal to 0. So it's gonna be minus, it's gonna be s, which is equal to minus 1. So let me just, this is not okay. Okay, this is gonna be minus 1 minus 1. Then P2 is going now is going to P2 and P3. So this will come from this one. Going to be equal to, let me put this, gonna be this S1, S and S there. It's gonna be like this. Okay. Minus B is 4 plus minus root square of okay. I think I've already solved this type of example. This is what this is the one I solved before. Let's move it away like this. So it's gonna be minus 4 plus minus 2 j over 2. So this is going to be equal to minus 2 plus j and minus 2 minus j. Okay. So these are our our 3 roots minus 1 and these 2. So now we can now write again our function here. F S. What is going on again here? Which is equal to, okay, we can say okay, S plus 3 over S plus 1, the bracket, then there we're gonna have S plus 2 minus j, then S plus 2 plus j. Okay, then we can now find our partial fraction, which is going to be Fs, which is going to be equal to K1, okay, over S plus 1 plus K2, which is going to be S plus 2 minus j. If you can see these roots, they are conjugate root, eh? They are conjugate root. We talk about conjugate complex number when they are really part is the same. Sorry. Please, can you mute your microphone? Okay. Okay, I was saying K3 is going to be equal to K2 conjugate. We talk about conjugate number where their real parts is the same and their complex number is different only on the sign. Like this one, we can see the real part is the same, is minus 2, but the imaginary part is different only by the sign, so plus and minus. So this is a conjugate complex number. So now, because it's conjugate, we're gonna have here plus 2 plus j. Okay, so now time to find the value of K1, K2, and K3. So let's find first K1. Yeah, K1 is there. K1 is easy to find. K1 will be equal to okay. Okay. K1 is equal to the formula is limits, Heaviside formula of S approaching, let's say, -1, then gonna be s plus 1 times s plus 3 over s plus 1 times s square plus 4s plus 5. So this one will replace just this one, cancel this one and that one. So we'll have minus 1, minus 1, minus 1 plus 3. Guys, are you there?
It's 2.
Yes.
Yeah, okay. Okay. So we're gonna have minus 1 plus 3, it's gonna be 2. And here what we're gonna have? We're gonna have 1 plus what? Plus 4, right? No, 1 minus 4, it's gonna be minus 3 plus 5, it's gonna be 2. So it's gonna be 2 over 2 is going to give us 1. Okay. So I think everyone have seen how I get this one, right?
Yes.
Yeah, okay.
Yes.
Okay, good. So gonna have 1 here. Okay. So let's now solve for, let me try to get another whiteboard. I don't know if there is a way to duplicate this one. So can I clean this one? Guys, can I clean this one?
ये
Yes.
वो
Okay.
ये 4 में 4 होता है.
Okay. So okay. Now let's find for K2, knowing that K3 is a conjugate of K2. So K2 will be equal to limits of S approaching minus 2 plus, then we're gonna have there S minus plus, I think also minus J, okay, times S plus 3 over S plus 1. Then there will be S plus 2 minus J, then S plus 2 plus J. Sorry, let me do this one. Okay. Plus 2 plus J. So we're gonna now can now do this. So this one will fall. Then we're gonna remain with limit of S approaching minus 2 plus J of S plus 3 over S plus 1 S plus 2 plus j. So now we can replace this one in where there is s. So here we're gonna have k2 is gonna be equal to, okay, when we replace, so let's just replace straight the limit. We're gonna have go there. Oh, gonna have minus 2 plus j plus 3 over minus 2 plus j plus 1 times minus 2 plus j plus 2 plus j. Okay. Okay. So this one, solving this one, we're gonna have, let's say, minus 1 plus j. Then here we can, this one is go with this one, we can come, this gonna give us 2j. This one we're gonna have, this one and this one we're gonna also give us, I think, minus 1. Gonna have here, gonna have, here is plus 1, sorry. Okay. So we're gonna have minus 1 plus j times 2j. Is it right? So this one,
Say,
yeah,
on the numerator, it's
yeah,
1
it's
plus.
plus. Yeah, you're right. I've seen it now. It's plus here. Yeah, 1 plus. So now we can now try to solve this one. So so we can have,
Sir,
yes,
I think on the denominator, sir, we have j minus 1. The first term. It's not negative j plus j.
no,
It's capital J.
yeah, I just make a mistake by writing. So it's
Yes.
minus 1 plus j, right?
It's minus 1 plus j, yes.
Yeah. Okay. Okay, it's minus 1 plus j. So this is going to give us k2 is going to be equal to 1 plus j over 2. Okay, so let's now see this one. When we do this that this is going to give us 2j, right? So this times is gonna give you minus 2j. Are we together? Then
Yes,
here,
2j squared.
yeah, and here we're gonna have what?
We're
2j
gonna
squared.
have 2j squared.
And
Which gonna be what?
Positive.
minus 1.
Minus 2, right?
Yes.
Minus 2, sir.
Okay, so this one now we can write it like 1 plus j. There we're gonna have gonna say we can have maybe minus 2, is it? Times 1 plus 1 plus what plus j, is it? Are we together?
Yes, sir. Yes, sir.
Okay. 1 plus j.
Hi, Bank.
Okay.
Right.
1 plus j. So this one can cancel that one. So we're gonna have minus 1 over 2. Is it? That's gonna be minus 0, 5. Are we together?
No.
What is your problem now?
Please, sir, can you start afresh from where our denominator is negative 2j minus 2? I didn't quite hear you clear there.
Okay. From here, right?
Yes, sir.
Okay. 1 times 2j is minus 2j, right?
Yes, sir.
Yes.
Yes, sir.
Then when we take j times 2j, it's gonna give you 2j
squared.
squared.
2j.
And we know that j squared is equal to what?
It's minus 1.
Minus 1. So it's gonna be 2 times minus 1. That's why here it become now minus 2.
Minus
Negative 2. Okay. Now I can factorize this one, is it? So we have 2 here, we have 2. Then I put then minus 2 here. Then I put 1 plus, so I can get the same thing here and here. So I can say, if I do this times, this one is going to give you minus 2. Then this times is going to give you minus. Are we together?
Yes, sir.
Yes,
Yeah.
yes.
Yeah. So now I can simplify these 2. I can simplify these 2. Then I find 0, 5. Knowing that K2 is equal to K3 conjugate, right? So K3, let's say K3 is equal to K2 conjugate. So this is going to give us minus 0, 5. So K2 is equal to minus 0, 5. K3 also is equal to minus 0, 0, 5. So are we right, guys?
Yes.
Sir, I have a question.
Okay.
Do you ever get a complex number that is the k that is a complex number?
Which K?
Can you have a k value, k1, k2, k3 that is a complex number?
Yeah. We can have that case. Yeah. It's not like it's going to give you always really number. No, you can have a K1 which is complex number.
Okay.
Yeah, you can have that. I think we're gonna maybe if we have time, we're gonna do some tutorials where maybe one or where K is a complex number. So now we got this one. Can I wipe this one? Can I clean it?
Yes, sir.
Okay. Okay. So we have the value of K1, K2, and K3. So now let us try to solve our problem. Okay. So this is gonna give us, let's go back to this. Gonna give us Fs, which is equal to which is equal to K1. What was the value of K1?
1.
It was 1, right? Thank you. It was 1 over which
1.
1 over S
S plus 1.
plus 1. Okay. Then plus or minus, right? It's gonna be minus. Let's say minus.
Minus
Yeah, it's gonna be minus
0.5.
minus 0.5 times, or let's say over S plus 2 minus J, right? Okay. Then this one also is going to be minus 0.5 over S plus 2 plus 2. Okay, so now we can apply the inverse Laplace transform, which is going to be L minus 1 of F S is equal to...
Sorry, sir.
Okay.
S plus 2 or S plus 2 plus J.
Hey, thank you very much.
Guys, mbona hana
Plus J. Okay. So let's do this one minus. So this is going to be 1 over S plus 1. And this one minus 0, 5. L minus 1 of 1 over S plus 2 plus J minus 0, 5 L minus 1 over S plus 2 plus J. Okay, so the inverse as, yes,
Finish this.
sorry,
There, please start afresh step 2.
which step 2?
The one you were writing.
This one. Okay. Sorry, let me just take this one. Plus 2 minus J. Okay, what is your problem? Do you understand how I get this one, right?
Yes.
Okay, so I just replace the value of K1, K2, K3. So then here, now I apply the inverse Laplace transform. We know that the inverse Laplace transform, according to the linearity, it's going to be the inverse of every single term in this equation, right? So that's why I apply inverse Laplace to this one. And then this one, we know that this one is a constant, so it's going to be 0.5 times 1 over this one. Then I apply the inverse to this part here and the inverse to the other part. Okay, is it okay now?
Yes, it's okay.
Okay, so now we're going to have f of t is going to be equal to, this one is going to be, which is 1 e
raised to minus t.
minus t, right? Okay, then minus 0.5. This one is going to be what? E. Then we're going to have on top minus what? Minus 2. Is it? Minus J times T. Okay. Then minus 0.5 E minus what? Open the bracket, minus 2
Plus J.
plus J T. Okay. So we can still continue solving this one. So then we're going to have E minus T We're gonna minus. We can put this one. Okay, this one and that one together. Then we're gonna see how we're gonna also combine these two. So we're gonna have 0.5, okay, times E minus 2t. Is it right? Are we together?
Yes, sir.
Yes.
Okay. Then what?
Plus
Plus
80.
E what?
Minus J. Ah.
Minus
Minus
JT.
2.
Oh, expand.
Then
Is it not, sorry, sir.
okay.
Is it not plus J?
Is what?
Is it not E plus JT?
Yeah,
Because
JT.
there's a negative here outside and J is negative
Yeah.
as well.
Exponent JT
Okay. Then
minus
minus what?
E exponent
E
negative 2t.
Negative 2t
negative
minus
2t
minus J minus E.
minus J.
So,
Plus.
No,
Then
not
down.
minus.
no.
Oh, it's gonna be, sorry. Okay, minus
Then minus E exponent
minus
Yes, minus.
minus E.
Sir,
exponent
E.
E
Okay.
negative.
minus to the exponent minus JT.
Okay, yes, I'll come to you. Minus
JT.
J T. Okay. Okay, then we can do this. Okay.
can we repeat this step, sir?
Okay, this step.
Yes.
What is your question?
I'm asking. Sir, I'm asking you to please repeat the last step for me.
Okay, so what don't you understand on this step? So that's my question too also.
From the bracket. Gale.
Okay, you remember when we are doing the exponential?
Yeah, we say.
Yes. When they give you this form here, so it can be E exponential this one plus E exponential that one. Are we together?
Yes.
Yeah, okay. So this is what we are doing here now.
Oh, sorry, sir.
Oh, saying
Okay.
I think all the E's inside the brackets should be positive, sir.
All the E, yeah. Because there's minus there, yeah.
Why?
Say I get it now. Thank you very much.
Okay.
Sure.
So what next now? E
Negative exponent negative
okay.
minus 0.5.
And 0.5. Okay.
Then 2 E exponent negative 20.
2T.
2E.
2E
Yeah, 2E. Then
plus
plus
E exponent JT.
plus what?
2E again.
E exponent JT.
E
exponent JT.
Exponential J.
Then
Two.
then plus E exponent
Negative JT.
T.
negative JT.
Oh, masenza.
Manje senzani?
Close brackets.
Yeah. Okay. J T.
T.
This is plus, right? Okay.
Yes.
So let's now see if there is a way to get the form that to get this form here, right?
Nah.
Sir?
Yes.
It is
Okay. You remember these two form here, right?
yes.
So let's see if we can get one of this form, so we can simplify it. Okay. From here, let's say from here we have this one here, and also we have this one is the same. So we can put this one in evidence, then we can remain with
Why mama 14?
okay, guys. I think there must be a mistake here. There must be a mistake somewhere here.
Right.
Okay. Let me just check something for you. Okay, guys, I think we made a mistake somewhere here. I think here it must not plus, it must not be plus, it must be times. Do you see the problem here?
Showcase. It's time, sir.
Yeah, it's not plus, it's times. Okay, so this must be okay. Oh, sorry. This must be times. Okay, let me put this one there. Okay. 2t, this must be times there, and there also it must be times. Okay, so can delete this one. Okay. Okay, let go. So this is gonna be what?
It's E.
So we can even remove also the other E. Yeah? Let's put it here. Let's see this one, because we have DE minus 2t and E minus 2t here, so we can put it there. Okay, so E minus 2t. Okay, are we together? Then we can open there. We're gonna have E plus JT, okay, minus, we can put like,
Where did we get that negative sign, sir?
okay, let's see, there must be somewhere. Okay, plus, sorry, Okay.
J2 times
Okay. Plus E times what? Minus
J2.
JT. Okay. So
Yeah.
this one can look like one of the identity there. Let's go. Which one? This one is equal to 2, right? 2 cos theta, right?
Mhm.
So this one is equal to 2 cos t. Is it? Are we together?
Oh, yeah.
No.
No, where did the cost come from?
Brackets we have a plus.
Sorry.
And phone is minus 2.
We're all alone. We are not together, sir.
We are not
Same.
together.
Why inside the brackets we have a plus?
Okay. So
Kwenzakala.
let me start from here, right?
Hayi namba ngibona bafethu hayi.
Okay. Let me start from here because I think people are confused because we made a mistake here, right? Okay.
Next semester.
Okay. So let's do this one here. You remember in math they taught that like when we have a, let's say when we have like a exponential 2 times a exponential 3, this can be equal to what?
A2 exponent 5.
A 2 plus. You remember?
Yes.
Yeah, okay. So here we have, let's say we have this e exponential this one. So we can put it in this form here, right? So this is what we are doing now. E is equal to e minus t. Yeah, minus 0.5. Okay. So because we have 0.5 here and this 0.5 here, we can open the big brackets and put 0.5 there. We're gonna have e. This is gonna be exponential minus 2t. Okay, this t, all right? Times e
Positive.
exponential, yeah,
T.
plus
J2.
j okay.
T.
Then we're gonna do plus here also plus,
Minus Z.
plus. No, it's gonna be plus, not minus.
Oh,
The minus is already there. Okay.
Yes.
Yeah, okay. So plus what? Plus
Minus
e minus 2t plus
Times.
oh sorry, that yeah, times
JT.
Minus JT.
minus
JT.
let me do this.
it's 80. Oh yeah.
Plus e j
Minus 20.
Minus 80.
jt. Okay, minus. Okay.
Yeah.
So we can close this one, knowing
Yeah.
that this one
And
and this one is also the same. We can also put it under the bracket, right?
Yes.
So I have e minus t minus 0.5 times this one, okay, times
E2 exponent negative 2.
e negative 2, right? So we open the bracket. We're gonna have now e
positive JT.
Positive
jt plus
E minus J.
minus jt.
JT.
So we saw that when you introduce that there is some identities that we can use for the complex number. If we have this form here, we can convert it to a 2 cos t. This is the, let me show you that identity is here. Let's go. You see this one, they say when you have EGT plus EG theta, it's going to give you this one. That's why we use it now here. We use it there. So we got this one is a cosine. So now we can write that our function, which is f of t, going to be equal to e minus t, okay, minus 0.5. That's gonna be times what?
Times A.
Times 2.
Times e.
So
to expand negative
2t
2t
times
Times
2
2 cos
2
A.
cos
t. So this and this one is
t.
going to give you 1, right?
Yes.
So this is gonna give you 1. Okay, so we're gonna have e minus t,
J.
and this one also. So this one also you can also write it in this way. So we're gonna have e. Okay, we're gonna have e. Then we put what there? Minus t. Okay. Can open the bracket. We have 1 minus e minus t cos t. Are we together?
Yes.
Yes. Okay. So can we move on?
Asphumle.
Can we move on?
Need a break.
Yes.
You need
We
a
need
break.
a break.
Okay,
Yes.
you have 2-minute break.
Okay, before break, say.
Yes. I cannot hear you.
Ubani manje lo umutelani? Say.
Yes.
At the end, I didn't get you.
This part here.
Yes, the last one.
This last one.
Yes.
Okay. Let me try to wipe it, then I will put for you. Can I wipe this one? On top here. Okay. Okay. Here we have, let's put this one. F of t, right, is equal to e minus t minus 0.5 times 2 is equal to 1, right? It's going to be minus e minus 2t cos t. Are we together here, right?
Oh, yes, sir.
Yeah, now you can see, So
Yeah.
we can put this, we can factorize this one too.
I got 0.5 times 2.
0.5 times this 2.
Minus 1.
It could give you minus 1,
Like,
right?
yes, sir.
Then we can also factorize this one. So we can put e. Because here we have e minus 2t. We know that e minus 2t, it's like, remember this one, it's going to be like e times e. Going to give you, you can see what I mean,
Yes, sir.
Okay, so minus 2t, so we can open, it's going to be 1 minus e minus t cos t.
Yep.
Okay. That's what we got here. Okay.
Thank you.
You're welcome. So you have 2-minute break,
Continue.
I can continue now, eh?
Yeah.
So
Yes, yes.
this one also, it's quite complex, but you must give me more attention on this one too. So now we are in the third case, which we have multiple real poles. So we have real poles, but they are the same. Like that's why I gave you those examples to solve. If you see, if you solve the first one, it was a normal one. The second one, you could have a complex. The third one, you would have all the roots are the same. You remember? So this is now when we said we have multiple real poles. So the case where the poles are the same, but they are many. They can be 3, they can be 4, but they are the same. So in that case, we have, let's say, the function n of ns of over this one. So this is the exponential. It can be 1, 2, 3, or 4. So how are you going to write it? So we're going to write it k1 over the highest in power, the one who have the highest power, plus the second one must be the power minus 1. The third one also must be this one minus 1, or you can even say minus 2, minus 3, according to the level that we have there. So now in that case, the Heaviside formula has changed. It's not the same Heaviside formula as we have used for the previous two. So the Heaviside formula now gonna be Ki gonna be 1 over I minus 1 factorial Ls to approaching Pi, the pole of that denominator. Then we're gonna do now inside. We open the bracket. We do the first the derivative of the factor under the pole or the denominator times this times what? Times this function. So where I is equal to 1, 2, 3, and so on. Are we together? So this is just a formula. So by solving an example, we're going to understand what this one means. So let's take now an example that is given to us. They say, let me use the board again. Okay. The example is 10 over. So the example given to us is, let's see, it was, I think, F S is equal to 10 over what? Let's see, 10 over what? 10 over S plus 4 squared plus 3. Okay. Okay. So we have S. Can you switch off the microphone? Plus 4 square times S plus 3. No, I think this one, let's see this one here. Okay, it's cube and square. Okay. Okay. So this is cube, this is square. Okay. So you know, in this case, so it means this one is repeated 3 times, right? So the pole is gonna be minus 4 3 times, and this minus 3 2 times. So in this case, we know that the pole we have P, which is equal to minus 4, and P is equal to minus 3. But this one is P1, P2, P3. Is it right? P1, P2, and P3. So let's say P1, 2, and 3 is minus 4. And P, let's call it this one P4 and P5. Okay, let me just write it like that. So in this case, they say we can now write the equation. How can you write the equation in this case? Well, we have f s, which is equal to, now they said to write the partial fraction must be written like this. They say k1 over the highest in or the factor with the highest power, and this one we're gonna do -1 and so on. So we're gonna have here k1 over s plus 4. The highest power is 3. Then we're gonna have plus k2 s plus 4. This is gonna be what? 3 minus 1, Gonna be 2. Then we're gonna have plus k3
over s plus 4.
s plus 4. Yeah, because this one is not the same pole, we can change it. So we're gonna put k. We can put it k. So let me call it k21 s plus 3 square. Is it plus
Yes.
k2
over x plus
k22 f over s plus 3. Okay, this is what we have here. So now, from here now, we need to find the AV side. The AV side formula for K1 is going to be what? Let's go back to the slides. They said gonna be Ki, where I can be 1. So our I here is 1. And 1 over I minus 1 factorial. So we're gonna have here, it's gonna be, because it's 1, it's gonna be 1 over, what is the value of I is 1 minus 1, and this is going to be factorial, is equal to what? What is the factorial of the factorial of 0?
It's 1, Mr.
Is 1, thank you.
That for 0 is 1.
Yeah, let now write continue writing all the formula. It's gonna be now there, gonna be, let me put that one. Okay, it's gonna be limits of s approaching to -4, which is the pole, right? And we open the big brackets. We have now a derivative of what?
Okay.
No, let's put there, the order of the derivative must be I which is equal to 1 minus 1 over dt 1 minus 1. Okay, guys, so this is the formula. You can see the formula, right? I minus 1, I minus 1. So I think this one, let me just change it because we are in S, it's going to be ds. So we're going to be d, we are in frequency domain. Okay, ds. Okay, then we have 1 minus 1. So of, now they say of what? Of this one, the root on the highest power times the function. So this is gonna be now, it's gonna be now s plus 4 power what? Power 3 times f of s is equal to 10 over s plus 4 power 3 times s plus 3 power 2. So we can simplify this one, we can simplify this one too. Then derivative of d1 of minus 1 is going to be 0, right? So in this one, it means that there is no derivative because it's a derivative on the order of 0. So it's 1. So there is no derivative here. So here we're going to have then limit of s approaching minus 4. So this one going to have 10 over what? Over s plus 3 square. Okay. So this is going to be, replace minus 4 plus 3 is equal to what? Minus 1.
Sorry, sir.
Yes.
Why you cancel x plus 4 cubed into x plus 3?
Oh, just a writing ish. Sorry, thank you very much, because you can see that one. Okay, thank you. Okay, it's this one. Okay, thank you. So this one gonna be minus 4 plus 3 is equal to minus 1, square is equal to 1, 10 over 1 is equal to 10. Okay. Are we together? Okay. So let's now move to the second one. Can I wipe this one? Okay.
What
do you say? Okay. So we have now the second one is K2. K2 is going to be equal to what? Let's go together. 1 over what? Over 2 minus 1. Is it? Because I is equal to 2. Factorial. Limit of what? Guys, let's go. Minus 4. Then we can open. We can open this one.
Open the bracket.
Brackets. Then put derivative. It's going to be with derivative. First derivative, second or third derivative. It's going to be
d2 minus 1.
Second derivative.
First derivative, because it's going to be 2 minus 1.
Yes.
Yeah. First derivative, ds. Then we can now, of what?
S
of
minus
s plus
2.
4 cube. Are we together? Times 10 over s plus 4 cube s
S plus 3
plus 3 square. So this one can cancel that one, is it? So we're gonna have now here first derivative ds of what? Of 10 over s plus 3
square.
Okay, let me just write it properly. Let me write it down here. I'm gonna have, yeah, gonna have limits, because factorial, this one factorial of 1 is 1, limits minus 4 of d ds of 10 over s plus 3
Squared.
square. So this is going to be equal to what? This is square going to be times that one going to be 20. Is it right?
Yes, sir.
Yeah, it's going to be 20 times what?
S plus 3 squared.
S plus 3.
Squared.
This is going to be power what?
2.
Huh?
Hey.
Guys, let's go derivative.
Power 3, sir.
How power 3?
Why power 3?
When they give you the derivative of, let's say,
I think it's gonna be 4.
it's gonna be 4. Okay, good. Thank you.
Yes, it's 4.
Yeah, it's 4. Thank you very
Quotient
much. Huh? Yeah, it's gonna be this gonna be, and this is the limit, so this gonna be 20, right? When you replace here, it's gonna be minus 1, gonna be 20. Okay. Are we together?
Yes, sir.
Is there anyone who has a problem? Okay.
Why
So,
S minus
so we have K1, which is equal to 10. K2 is equal to 20, right? So I can wipe this one. Let's now solve for
Action.
K3.
Excuse me, sir.
Yes.
Is that derivative correct? Is it not supposed to be negative 20 over x?
Yeah. It's gonna be negative 20.
Negative over x plus 3 cubed.
Yeah.
Because we're gonna bring up the x plus 3 squared to the numerator.
Exactly.
And then
Yeah.
differentiate
Yeah,
and
you
then-
are right.
Okay.
Yeah, you are right. Sorry. Yeah, you are
Okay,
right.
thanks.
Thank you very much. Huh? You are right. Okay.
How am
I'm lost now.
You are lost. How are you lost? Okay.
Very
Okay. Let is the derivative. Let's go. We have, let's say, we have 10 over what? S plus 3 cube. Is it?
Yes.
Yeah. Derivative. So, is square. Sorry, square. Okay. So these two here. Well, when we have a derivative of, let's say, 1, or let's say u over v. How do you do it? Hey guys, how do you do this the derivative? This is high school, eh? U over v
V
is equal to what?
derive V, then multiply by V minus OU.
Okay.
Derivative.
Okay. So
Then
let's say now we have v square. How are we going to do it? Okay, so you know that is the formula. So this one gonna be 2 times 10. Okay, are we together? Guys, are we together?
Yes, yes, sir.
Okay, so when they give you now, they say derivative of v square is equal to what? Okay, you know. So this is basically what we are going to do. Derivative of this one. This one is our v square. This is our u. So we're gonna do this one because we're gonna have like u prime times v times v minus let's say u times v prime. Is it?
Yes.
Yeah. Okay. So you over what? Over v square. So this is the formula. Okay. So this one is your v, and that's one. So that's why the guy was saying that when you derive this one here, this when we have v, let's say m, gonna give you m times what? Times derivative of what? Derivative of v prime times v m minus what? 1. Is it? Is that the formula, guys? Eh? Guys, is this the formula, right?
Yes, meneer.
Yeah. So if
Yeah,
if our m is equal to 2, so then we're gonna have here we're gonna have we're gonna have 2 here. Let's say 2 is there. Okay. We're gonna have 2 there times what? No, let's put only 1 and 2 here. So just to avoid you to be confused. So 2 times this one of v and 2 minus and 2 minus 1. Okay. So guys, I think today we finish by here. You're gonna solve this one yourself, and next time we'll start something else.
Sir,
Yes.
where can I get the recording of this class?
I will put them on Blackboard.
Oh, all right. Thanks.
Yeah, I will upload. I think you guys are all on Blackboard, eh?
Yes.
Yeah, I'm going to put them on Blackboard. So
Can you please share the slide again, sir?
sorry.
Can you please share the slides again?
Okay. Okay, I can share them again, no problem. I will even put the slide on Blackboard too.
Oh, yeah.
Yes.
Are we having an evening class later?
There's no evening class today. The evening class is on, I think, on Wednesday and Friday.
Sir,
Yes.
when is the prep?
Tomorrow.